another appendix to the discussion. HCA, the ones that gave us data, that's the paper, the simultaneous equation paper that we are going to talk today about. And I find my slides here. And so that's why it took 10 years. Because it was, and I think it was Alex, if Alex had agreed when you got the first rejection from the accounting review to split this paper in two, I bet you one piece would have gone into the accounting review, the other piece would have gone somewhere else. And the tapes that were called out a quarter stubborn. I have worked with Alex now 25 years, so we can call each other stubborn. We are good friends. We continue working together, so obviously we get along very well. Okay, you want to have a little break, and then we do continuity equations. And I'm going to pick up Denise's slides to just kind of generate a little bit of discussions that I want to have with you. Okay, I want a little bit of advice on how to rewrite that paper. Because you all read it, correct? Good. Around the United States, no cell phones at that time. Okay? And the way switches are basically a complex computer. Okay, and typically are two computers side by side, so they have integrity. One crashes, the other one is alive. And the way they extracted the data from that is every 2 hours is done a magnetic tape. Do you know what a magnetic tape is? You still know that, correct? And then the magnetic tapes were taken to a data center, read in, and then the records were split into pieces. And these pieces were finished up in the bills. And there were 20 bills per month. 20 bill cycles per month, meaning each one of you that was going to be billed by AT&T would be allocated to one of those 20 days. And so what we wanted to do is model these relationships. And a guy in our team, a guy called Andy Sherman, was a physicist. And when we started trying to build equations to this, he said this is called, in physics, continuity equations, where you pick up a variable for one stage and represent it in the other stage, and then represent it in the other stage, etc. And so this was the idea of continuity equations, that we created equations that linked the different pieces of HCA's process. So, and instead of doing this for AT&T, we did actually this for HCA. And basically was a, I don't remember this, so I'm just going to do this symbolically. We related, I think was a warehouse, hospitals, and patients, consumers. And I think it was one warehouse and 9 hospitals, and I don't know if we got to the consumer level or not. But what we want to do is create equations, said that for every tape that you receive, in 5 days you finish up having a record, and the record would have. And Alex had this idea of creating continuity equations with timing on it. So basically, the example I always use in class is you sell. Okay, when you sell, you collect, let's say, 40% in cash. Then, however, 60% will be credit. And of this credit, maybe in a month, and then, let's say, 30%, and I'm using the total 100%, so 60, 30%, meaning half of this will pay in 30 days, and will pay minus 2%, because that's a discount you give. Then maybe of those 60, 20 will pay in 60 days the full amount. And maybe, so those 60, 30 will pay this. Just don't remember here. Let's say 20 will pay the full amount in 60 days. Hold on, that's right, this is the days. So let's say of the 60%, let's say half of them, 30, will pay minus 2%, 20%, 20 of those 60 will pay 60 days. Let's say 5% will pay 90 days, and 5% will never pay. Will never collect. So 40% paid cash, 60% got credit. Of those 60, 30 paid in 30 days with a discount of 2%, 20 paid in 60 days with no discount, 5% paid in 90 days, and 5 never paid. So you can build an equation basically with the timing. And particularly if the sales are cyclical, or particularly very large in the end of the year, you're going to have a much better prediction if you say cash in period 1, this is period 1, is cash in period 0 multiplied by 0.4. Okay? And then you're going to have, of course, every period you add to this. So it's a cumulative effect. And so this was kind of Alex's idea of putting timing in this effect. Okay, and I'm going to ask a question right now for you to think while you are talking about this. Instead of balance sheet and income statement, can you model the economics of a firm using continuity equations? Using relationship equations? Okay, keep thinking. So the way Alex describes this is IT-enabled business processes. A business process set of logically related tasks performed achieve a definite business outcome. Modern information technology is possible to measure, monitor business processes at the precedent. I just, knowing this reference, this is not Alex, this is Mike Alice. He loves Davenport and short. Continuous auditing method can utilize IT capabilities to capture business process data at the source and in the disaggregated and unfiltered form. And so this is basically the idea to model in a disaggregated way and come up with some level evaluations. Okay, and then you can kind of model business process two ways. The environment highly automated, tightly coupled business processes enables CA based on continuous monitoring process controls. Unfortunately, there are numerous enterprise environments where process controls are either not automated or their settings are not readily accessible. In an environment such as a loosely coupled legacy data process, do you know what a loosely coupled legacy data processing system? This is Alex jargon. This is an environment whereby you might have an ERP and you might have a legacy system. And in order to make them work with each other, you write a thing called middleware, which is what we call loosely coupled, meaning you finish up having transforming this to that, because the ERP is not designed. Our procedure has to be data-oriented, transaction tests, and analytical procedure. Technology label of data-oriented, a data warehouse. You don't need a data warehouse, but you can use it. Okay, data-oriented automation of substantive testing, automation of transaction testing, formalization of the business process rules as a transaction validity constraint, verification of transaction integrity and validity. And what you want to do is detect exception and generate alarms. Okay, the basics of continuous auditing is this idea of alarms. What is always the same story? The story is you have a business process here, and you measure it. You have a standard, which is what should be the level of data in that business process. And then you have a variance. Could be positive and negative. If this variance is larger than your standard for variance, you issue an alarm, an alert. Alert or alarm is the same thing. It's always the same story. And this is also the same story of continuous monitoring. You have a measurement of the process, you have a standard. If the difference is noteworthy, you issue an alarm. And when we did the continuous auditing stuff at AT&T, we had different levels of alarms, we had different people that get alerted with an alarm. That's always the same story. Now, what's the difference between continuous monitoring and continuous auditing?
In terms of responsibilities, I think that the monitoring falls under the realm of management, and continuous auditing, so this is more on the preventive side. Actually, they're both on the
No, you are in the right track there.
Yeah.
Monitoring is done by management, auditing is done by auditors. In order to use monitoring data for assurance purposes, you need to have monitoring there. You can't do continuous auditing without some degree of monitoring. So there is typically what I talk about, there is a layer of continuous monitoring, and on top of that, there is a layer of assurance. Although there is a lot of things you monitor that you don't assure. And and what is this process of monitoring? It's always the same thing, comparing an actual with a standard. Now, is this novelty for auditing? No, there are a lot of monitoring happens everywhere. In manufacturing, you have your kid in the backyard, and you say, don't go to the front of the house. You are monitoring, you are watching it. The moment he walks that way, you say, come back. Okay? So what is your model? That this line here should not be crossed. The moment you detect the line being crossed, you go into some action. Now, if you are talking about large factories with large paper mills and et cetera, all kind of equipment with numbers on it, and very often those, if a particular marker goes too high, an alarm sounds, makes a lot of noise. Same kind of concept. But manufacturing is doing alerting and alarming for decades, while we in auditing haven't done that very much. And so if you exceed the allowable variance, what you are doing is you created an exception, and you issue an alert. So, verification, transaction, validity, detection, exception, generation of alarms, automation, analytical procedures, selection of critical business process metrics. What are you selecting? The metrics. What are you measuring? And then you want to develop continuity equations that allow to call your attention if the continuity is broken. One of your continuity equations is in detection of anomalies, and so it makes this difference between anomalies and exceptions. And we're going to kind of talk about that in a second. So that's the other point he always makes on this, is in auditing, first to apply analytical procedures to identify potential problems, then focus on the entire transaction testing of the identified area. In continuous audit, the sequence is reversed. First, you apply transaction tests to everything, and then you do what I call audit by exception. Remember, in the first day of class, I designed, say you do interim work, this is year-end work, and what I said in the continuous auditing environment, what you have is audit by exception. You don't do that interim work, you already have the system designed and exceptions mapped. What you do is, if you start getting a lot of exceptions, then you go and start finding out what's happening. It's the other way. Actually, I have been talking about this for 30 years. 86, 96, 2000, yes, now 30 years exactly. And finally, I started seeing some people talk about audit by exception, which is interesting. And what this is actually just a little chart saying that you collect the data that you have into a data warehouse, and then you apply your analytics on the data of the data warehouse, and people examine the exceptions. So at Itaú Unibanco, what they had is, at that time, Unibanco, what they had is 1,400 branches being monitored, and the data went into the enterprise system, and every night they got a set of reports of controls that were violated. And they had 4 people that basically examined those controls and those exceptions, those alarms, and decided if about half of them got verified, the other ones were let go, based on. And so we have based on the events. Verifying transaction fact and validity, a procurement example. Basic procurement business cycle. Purchase order, shipment received, voucher payment. Identification failed transaction test, automatic alarm to resolve exception. Causes of the exception. Purchase order has 0 order quantity. When does that happen when there is a 0 order quantity?
Forgot to record?
Yeah, it's a blank purchase order.
Arrow input, and you should be 10, but
yeah, it's a bad input. Yeah. What did you find in the contracts? You had some 0 orders there, didn't you?
Oh yes, but those weird numbers, it shouldn't be real. So
Yeah, and the other thing that sometimes you find is like rentals, and every month you have to pay your rent. There is not really a purchase order there, so they generate a blank purchase order just to generate a payment of rent. Receive item has negative quantity, non-existing vendor number, invalid paycheck. So these are all examples of data validity exceptions. That's validity. Now consistency. Changes in purchase order vendor number. Discrepancy between totals and sum of line items. You know, this is something that you know what they used to do. They used to have a 10 key, and they added each item to see if the addition on the voucher is correct. Today, you know, computers don't do a lot of mistakes, but you do also verify sometimes because there might be exceptions in the program. Discrepancies between matched voucher amounts. Gross payment amount is smaller than the net payment. So the amount that you pay is larger than your invoice. Referential integrity violation. Purchase without matching requisition, like a 3-way match matches 3 things. What are the 3 things that are matched in a 3-way match? You have a purchase order. Okay, you have a warehouse receipt. So what was received? And what else?
Invoice.
Payment. And why would you have these things not match? You pay the amount of the payment. Why would they not match?
You get partial orders, but
Partial orders is one case. What else?
discounts.
Discounts given. Or maybe the company didn't have the money to pay and just paid a little bit for credit. That happens enough, bad cash flow. Or there is a dispute. So there's a lot of reasons why this could happen. Do you remember this is the example that we showed to the IASB? And where we had there, I don't know the numbers exactly, but we had like 600,000 transactions, of which 5% didn't match. And for you that did audit, you know that 5% is not a terribly high number for this kind of test. Now, what's the difference here between automated three-way match and manual? Because the manual three-way match, you go and check 20 of them and see if they worked. Then you find one that's wrong, you follow it up, figure out what it is, and discover that was a partial order or something like that, not a big deal. Well, but if you're doing it with a computer, you test every single one of them. Which one do you have more confidence?
The computer.
Of course, because you've checked, your amounts seem to be reasonably right, but you don't find one exception, you find 30,000. So you guys have to do exceptions there, or you have to figure out something to deal with it. Okay, and so basically, what we try to do is write equations that link the pieces of the value chain. And we did this at AT&T, but that work was not published. We couldn't publish it. It was prepared. Okay, and so we repeated this in the HCA. And so what we were trying to do is statistical models capturing relationship between various business processes can be used as an expectation model, meaning expecting what's going to happen. And this is what I said. Andy basically said this is like physics, and there are a lot of examples there. And so we actually tried three methods. One, linear regression. The other one, simultaneous equation modeling. And the third one, multivariate time series modeling. Okay, and basically, regression was not the best, was nearly the best, but not the best. But we finished up at the end wanting regression because it just was simpler, easier to use. Okay, regression has this great characteristic that is extremely robust. And I know many of my friends don't like when I say this. Don't like when I say this, but you can violate many of the statistical assumptions of regression and it's still reasonably reliable. So, you know, like you have all these things about normal distribution and this and that, and we actually went. And so this is actually what I described to you before, is a timing thing. Vouchers, reception, purchase order. So there was a delay here, there is a delay here, and what you finish up is doing reasonably better in predicting values. So if you said without the timing variance here, without the delay, you just still had a representative model, but wouldn't be as accurate as with the timing. And so it actually was very nice what Alex done there. Was Alex and Jiawu, this was Jiawu's dissertation. And actually they measured like the average delay between one process and the other and modeled it with an average delay. And so this is what it is. Receive T2, purchase order T1, voucher T3, receive T2, and then the relation. Are partial deliveries allowed? Are all orders delivered after exactly the same timeline? Are there any feedback loops? So these were. Are there any feedback loops, by the way? The feedback loops are driving differently to the grave. Why? Because some things are PO is wrong. What do? You send it back, they fix the PO, send it back to you. Isn't that what happens in business? Crystal is looking very puzzled by this. That's what, in business, you constantly are fixing things. Something was filled up wrong, person without right to approve, etc., and you fix it. The thing that we did in process mining had 5 main type of paths of transaction that explain 85% of the variance, or something in that domain. However, there are actually around 700 different paths, what Tiffany calls variants. And many of those paths were just kind of redoing things, go back and forward until things are right. Okay, and so it's actually, this is the equation that they picked up, that they managed to do. And this is just a regression-like model and representing each one of the stages of the process. And does this remind you of something that I just showed you? Observe is predicted PO minus variance. So here is the predicted PO, this is the variance. And of course you can do this for any element of the thing. And then if the variance, acceptable threshold of variance, usually chosen based on alpha confidence level, statistical investigation rule. So what's the name for this guy here? That's the variance, that's the statistical investigation rule. How do you determine this? You probably look at the distribution, say I'm willing to work with 2 standard deviations. And so you take the standard deviation and figure out the result. Are you confused? Did I confuse you? Okay, so we already covered this. So actually what we did, we seeded errors and see how well they were picked up by the procedure in variances. Yes? What does it mean, seeding errors?
Yeah, I read that a lot, but I'm not sure what it means.
Is you have a distribution or you have a population, and what you want to find out in the situation is if your errors are picked up. So you create some transactions that are erroneous. You throw it in your population and see if your method catches it or not. And very often you see the population with errors to compare methods of detection. Yes?
So come back to the equation. These equations are dynamic. It's not, it's decided by the specific business process. That's right?
You run regressions typically, calculate maybe the delay that you have in there, yes, and see what is the best fit regression there. And that's how you calculate it. You're right, it's the specific business process that you are actually modeling. And the more data you have on the specific business process, you know what the normal is and what the abnormal is. And I very often say that you can decompose processes in their own components. So a natural thing that you can do is you have your sales. Your sales over the year grow this way. Okay, and then within the year, you have a year-end factor that they sell back. So you can kind of decompose your total sales into cyclical part of the sale, periodic growth, etc., etc. And some of those are reasonably easy to model, some of them are complex. So you need to kind of figure out how you're going to do it. Yes?
I have a question. So it seems like most of these equations are just involved in the business process. Is there any way to link it to the financial accounting, like entering into the general ledger, or does that make it too complicated?
That's your dissertation. But that's, remember I asked you that question from the beginning.
Yeah.
I said, you know, I always say this, but I have absolutely no way to prove it, is that you probably can represent much better business by writing equations than by balance sheet and income statement. Because, you know, a statement like, for every dollar I spend in advertising, my sales go up by $3, okay? So 1 to 3 ratio. What I'm saying here is no novelty. When an advertising guy comes in and tries to convince you to put dollars in his advertising scheme that he gets commission, or he basically applies it for you, they always come up with quantitative schema of what's the incentive you get for newspaper ads, for TV ads, or TV ads that are specific for an age bracket, for TV ads that are specific for age bracket, for a particular region, and goes on and on and on. And they have this modeling that they do. And you could, for example, create relationships between negative Facebook comments or bulletin board comments of a product and your customer service function. And you know, and the nice thing about this is there is a timing twist, T minus 2, 3 minus 3, etc. And you relate the different parts of the business model. Okay, it's a very different line of thinking. And I joke, say this is better. I don't know if it's better. It's another way to look at it. But I don't think you thought that you could really, and you know, people have done modeling of the financial statement, but they say assets equals liabilities, assets equal liabilities for owner's equity, and then just kind of put the equations on the financial statement. But that's not really modeling the way I was talking about. Yes?
Yeah, I was noticing in one of the papers I read that dealt with audits and reviews of the financial statements, it seems like the number one thing, and this is actually what I remember doing too, is comparing to the prior year.
Yeah.
And if there's any change, then just asking the client and then explaining the change. So it just didn't seem like there was any advanced. I feel like with all the intelligence out there with financial modeling, I'm surprised that it's not done on the audit side.
That's a perceptive comment. That's a perceptive comment, and I always usually say that. I say that our method of measurement is very bad at this moment. Meaning there was a time that FIFO and LIFO made sense. Okay, but today, you know, you have a barcode and everything. Okay, you know which item you have in inventory. You don't need to do FIFO or LIFO. You know how much each one costs. Okay, and this is only one part of the story, which is the physical asset part. In the old days, companies are valued by their physical assets. Okay, and that's why you had balance sheet and income statement. Today, companies are not valued by the physical assets. The same thing I want to say about ERPs. If you pick up an ERP, how many of the reports in the ERP are balance sheet income statement? Just a few. How many other reports there are? Thousands. And what are these things? The things you need to run your business. Your human resources, your salaries, your intellectual property, your supply chain, etc. So they're all there, and certain parts of the business need to run it. When I finished my PhD, I went back to Brazil, and I ran largest computer center in Latin America at that time. PUC, Brazilian Pontifícia Universidade Católica, Catholic University of Rio de Janeiro. Had a big IBM machine. And what we had there is this whole set of physical assets that we measured. And you know, we did this for clients and et cetera, et cetera. But these were file systems. What does it mean? Payroll was separated from accounts receivable, was separated from payables, so each one was separately. And then when we tried to merge them, Students were paying, but they were not registered. Students were registered, but they were not paying. And there's this whole mix of things. Since ERPs came, these integrated these records, and you don't have that kind of problem anymore. But at that time, those were physical assets that you are measuring. Today, companies, that's why the Ball and Brown equation gives you such a bad R squared. What are the regular R squares that you see in the papers that come in here doing Ball and Brownish type of things? Oh, we don't know what Ball and Brown is.
3%.
Yeah, 3 to 7%. That's what it is. What were the values at Ball and Brown times? In the 60s, early 70s. 40 to 60%. So at that time, your financial variables explained 40 to 60% of the variance of the stock price. Today, they explain 3 to 7%. That's the ranges I have seen. And there's actually a couple of papers looking at that. Why? I am destroying your faith in financial accounting.
We agree with this.
You knew about this?
Yeah, apparently more information is available about much more than just financial statements, so it's reasonable to see this.
Like what?
Like media coverage, we have Twitter, everything else, like monitoring it for
But before Twitter, the numbers were already pretty mediocre.
press.
Yes? I think that's part of it, yes. Part of it is the information set is larger. But the other part of it is that the things you're measuring are different. Meaning, ask Bill Gates, what's the value of Microsoft? Is our people. He doesn't say the $40 billion that they have in cash. I don't know if they still have it. They used to have a lot of cash. Okay, Google has a huge amount of cash in their balance sheet, but they are not called Google anymore. They're called Alphabet.
Yeah,
Alphabet. Is it Alphabet?
yeah, Google is now a subsidiary of Alphabet.
Yes. And they have a lot of cash. Okay, but that's not what the main asset. Well, what is the main asset of Google? IP, intellectual property, the algorithms, and this huge supply chain that they have with that technology. You would be very surprised what Google knows about you. Think about it. Every search you do can be, to a certain degree, assigned to you. Well, not all. If you go on an anonymous machine and anonymize everything around, you can't be identified. But by the things that you look for, already identifies you. And remember, you have 3, 4, 5 variables, they converge, they give a good story. Okay, but that's actually the problem that exists with accounting measurement at this moment. And doing this kind of thing, representing things by equations with relationships, is a little bit more realistic way to measure things. Can you imagine, however, if you publish your financial statement by equations, how the public would react to that?
It could be.
Huh? You would like that, Edward.
It could be.
But no, I think
XBRL extension.
Yeah, you say XBRL. I'm very disappointed with XBRL. I was kind of in the beginning of XBRL. Gary Previtz from Case and me went to talk to the XBRL task force. The second meeting, official meeting they had in Philadelphia. And we argued strenuously for an XBRL at much lower level. But what they decided to do, meaning just if you haven't heard of XBRL, is they basically pick up exactly the numbers of the financial statements and convert it to a tag number. So there is no change really, it's the same number, except And there is, you know, you saw the paper yesterday. There were a few times that there is some adjustment. You saw what Elizabeth was saying yesterday. But it's the same number. It's the same number. And the problem, that's, so when they asked Elizabeth there, and Val was talking about this, what is the benefit of XP? Well, there is one. It's electronic media, so it's easier to transmit. Is there any other value? No, it's the same numbers. And then Roman did this dissertation, which compared the XBRL numbers to the CompuStat numbers. And there are differences, but why wouldn't you have the differences? The CompuStat guys force the numbers into the right box. And sometimes that account name is not the name that should be there, but you don't have another place to put it, so you put it. I wrote this paper easily 25 years ago, comparing value line and CompuStat, because I had value line access at Columbia. And we found a lot of differences, and what we discovered is that the value line guys were mainly analysts, and they kind of interpreted the numbers more. The CompuStat guys did it very mechanically. I never got a paper published. Accounting Review rejected it twice, okay, just before its time. Today, everyone is excited about comparing databases. At that time, no one was. Turns out, my co-author, without me knowing, submitted it somewhere, and it did get it. A few years, 10 years later, or something like that. It was my PhD student, David Yang, University of Hawaii. But as I say, some papers just don't get in. But these days, they get it, because there are enough journals around. So never let a paper of yours, unless you think it's wrong and it's stupid, don't let a paper sit. Keep it in the pipeline and keep submitting. It will get it. And just because a paper gets rejected many times, doesn't mean it's bad. What, if it's not bad and it's rejected many times, what does it mean? Say it, you say things the way they are. The referees are stupid. Meaning, can referees make the mistake? They are not. They, of course, they make mistakes. The other thing is that they are specialists, typically referee. And if something is continuity question, never heard of it. Must be wrong.
Jerk reaction.
Yeah. Yeah. And sometimes, and of course, this paper is not very easy to read. So this is what say the error seeding procedure. And what Alex said, what we did on this one, this was Jiaowu's dissertation. And poor Jiaowu took 10 years to publish it, but Jiaowu did fine. He went to UMass Amherst, not UMass Amherst, one the other UMass, where it's Hanover or wherever that is, and he got tenure, he's department chairman, he done very well. Yeah, that school didn't require a lot of publications. But maybe a couple of you met Jiaowu a couple of years ago when we had a party in the national meeting. We keep in touch with him. Okay. Okay, and then this is the whole thing about false positives, types of alarms, and this is joining. Remember what I said about false positives and false negatives. It's always like this, or let's say many times like this. This is your population flowing, and you say, this is my cutting line in my algorithm. These are the positives, these are the negatives. If you change this line down, you get more false positives. If you change this line up, you get more false negatives. So, you know, I always happens to me. I talk to businesses, and they say, we're getting, or auditors, we're getting too many false positives. Very easy to reduce them. But what happens? Well, false negatives. You have a population, things are either positive or negative, correct? Could be boundary, I guess could, but not very often. And if you squeeze your selection criteria, you are going to have more, you're going to have much less false positives, but you're going to have much more false negatives. Is there any procedure that has no false negatives?
Yeah, sure. You can say everything is an anomaly.
That's one way to do it. Or the other way, you create a very stringent that only finds positive. But what that thing is going to do, in general, if there is any variance in the population, it's going to have a lot of false negatives. Okay? And so, I reviewed the paper for the accounting review a couple of weeks ago. Okay? And he is doing all kind of beautiful analytics, machine learning analytics, on this population of fraudulent financial reports. And he has like 50 fraudulent financial reports picked up by comment letters. And he has maybe 10,000 population. What's the problem with that story? First, he's squeezing too much information out of very little data, 50 data. Second, he must have an enormity of false negatives in there. She's looking very worried here. And that's the problem with that particular type of population. I accepted the paper, and to my surprise, the other referee accepted it too. And why did I accept it? Because I want you guys to read that paper. Because it has all these pre-screening methodologies. I think I know who the author is. And it's a beautiful piece of work analytically, but I don't trust the results in iota. And I don't care, because it's very interesting, the pre-processing that he does there. He brings all this literature from the physical sciences in, and there's a beautiful piece of work, and I want that paper to be published. It might already be in the accounting review, might already be in the pre-published thing, because I saw the review of the other guy, I accepted it too. And this was my second round, so with my comments it won't go for third round, and with the other authors, so I think he's probably working with the editor to clean up a little bit and accept it. But beautiful piece of paper. So you always thought that papers get accepted because they're right and they are great. This paper is great, but he's not right. You understand what I'm saying? He's not right. It's just not possible. Okay, extending this conversation. I was talking with this CPA firm whose name starts with K or D or E or P, okay? And they actually have a predictive analytic tool that they are using, and they asked me to review this prediction. And when I looked at that, it was deja vu all over again. So this is a very similar kind of problem that this paper that I just had referred happened. You know, they created a model based on known comment letters, and they instead of comment letters, they used also restatements, which is a little bit of a different thing, mixes a little bit apples and oranges. But I liked it better actually because they used the restatement, because it gave him a little bit bigger population. And the error of the false negatives on the other one is probably reduced a little bit by using restatements. But there is still a lot of things that are wrong there. And they modeled on that separation, and they have this prediction of fraud or not. So these things are being used, and I was very happy at that moment that I had accepted it. Okay, you have the paper, so and you read it. Just have a look at this. This is actually very interesting work, and I am dying to find another company to do continuity equation modeling. Okay, but this time I want to do continuity equation modeling, not in a hospital and drugs, but I want to do something like three-way matches and entire financial report or something like that. I want to do it different. Okay. I'm kind of running out of time. I just wanted to show you some slides here. So instead of you working, I'm working. Okay, so this is you saw these slides. Okay, and I think the advantage of working with professors that are working and publishing is that you see the difficulties that they have. And I always say the highest correlation between someone being publishing, is his advisor publishing. And that's maybe a misstatement, because maybe he's not your advisor, but someone you work with or you see how they work. And we actually got this thing back from the editor since Denise presented it. And that's why I wanted to just show you what I just did with this. I took off the entire literature review out of this, gave it a new name, and that's a different paper. And now I'm kind of trying to fill up the gaps here, kind of fill the logic, reorganize a little bit, etc., etc. And candidly, I think the editor was totally right. I didn't even argue with him because I felt the same way as him. But you have 3 authors, you know, you have a little bit of a different view of the world. But this one, we didn't have a problem of not cutting into 2. You know, the thing I show in continuity equation, at the end of the paper, Alex has this thing that he put in there, automatic error correction. So what he does is he finds a transaction that's an anomaly. You read the paper, so you saw this. Maybe you don't remember it, or maybe the paper was too dense. And what he basically does is get the best estimate for that particular transaction and replaces the value of that anomaly for the best estimate. And that really blew the mind of the referees. And I wish, if we had the foresight, that at that time we had pulled that out of the paper, made it a different paper. And maybe you both would have gone in easy. So that's another thing to learn here, is don't make your papers too complicated. Try to make very sure that the tension you are getting, you resolve the problem that you are dealing, don't do much more. And so what we did is we took the whole thing there, but we have a dilemma here. And I'll show you what the dilemma is. I think I have it here. This is the dilemma, okay? This is actually the pieces of the audit and what kind of analytics you can use with it. Now this is drawn mainly from the literature. So I take the literature out. This thing kind of stands by itself. So what do? You put a reference and call the other paper. But I don't think that's a graceful solution, but I don't have another one. So I think I'm going to put this table, and there is another table like this a little bit later in the paper. I'm going to put them both in both papers. And what I'm going to do is put a reference from this to that. You have any better solutions? I have a little bit of a discussion with Denise about this. And I'm not ready to go and read the 220 articles that she read, so I have to defer to her judgment sometimes. But this is really the kind of the 2 tables that I think we have a little bit of a little problem. Notice that they are kind of similar tables. They're kind of similar tables trying to tell a little bit of a different story in variables, okay? And this all relates to the Cushing and Lobeke paper. And what is the Cushing and Lobeke paper? Is a paper that Cushing and Lobeke interviewed the Big 8 at that time and came up with a schemata of what are the steps on the audit. And we link it to that one. There is, I think, a fundamental problem with this paper is that I think with analytics, you might change the way the steps of the audit. I think with analytics, for example, we are talking in the radar meetings about what analytic to use then, and they were kind of obsessed with this thing, audit planning, substantive testing, the 4 steps that they use. And it was seeming to me that those analytics work everywhere, at least a few of them. And that kind of violates the way they think. So let's see what happens. There will not be a resolution of this publication until this course is over. Actually, I think this paper probably will get in by that time, but I don't think the literature review paper will get in. And reading 220 papers and classifying it, only Denise can do that. But you'll see, I added a paper to your list, which is the GDM evaluation by Catherine Caduce and a couple of authors. They had a lot of papers there. And there is one, which is the International Literature Review. I'm still kind of inclined of asking you to read it, to give you a broader view. I'm sorry, I don't know the entire literature, no one knows the entire literature, so I find something interesting, I want you to read it. It's the advantage of still doing research. Anyway, time to go?